Continuing on with regular polygons. Example 2. What is the relationship between the number of sides of a regular polygon and the sum of its interior angles? It's a lot of words. Let's fill in the chart. The pattern will become clear. In a triangle, how many sides does it have? Yeah, it's 3. That's as easy as you think it is. How many triangles can be made by the diagonals? Can you even make a diagonal? Can you make a diagonal through? That's not going to a corner. That's going to the middle of the triangle. That's not a diagonal. How many triangles can you make in a triangle? The answer is 1, because it's a triangle. That's all there is. It's not more complicated than that. What do the angles in a triangle add up to? Yep, they still add up to 180. We've played this game before. In a quadrilateral, how many sides are there? There's 4 sides. How many triangles can you make by doing a diagonal? As we've done before, you can divide it into 1, 2, 2 triangles. Each of those triangles has 180 degrees in it, so the total is 360 degrees. We just did the pentagon like in the previous page right here. How many sides does a pentagon have? 5. Pentagon. How many triangles can we make? We were able to make 1, 2 lines, which makes 3 different triangles. Each of those triangles is worth 180 degrees, and so that's why we got 540 degrees as the number of degrees inside of a pentagon. And now we keep the pattern going. How many sides does a hexagon have? 6. How many triangles can it be divided into? 4. Each of those triangles has 180 degrees in it, so the pentagon should add up to 720 degrees in total. Are we noticing the pattern? 3, 1, 4, 2, 5, 3, 6, 4. So if you were able to draw a 20-sided polygon, it has a fancy name, I don't know what it is, but how many sides does it have? It's 20, because it's a 20-sided polygon. Okay. Here's where the pattern kicks in. How many triangles can you make inside of a 20-sided shape? I'm hoping you're starting to learn the pattern here. There should be 18 triangles in there. 6, 4, 5, 3, 4. Do you notice it's always 2 less, 2 less, 2 less? 2 less. Each of those triangles is worth 180 degrees, and let's figure out how many degrees that is. 18 triangles in there, 180 degrees each. I got 3,240 degrees inside of that 20-sided whatever-agon. And here's where we create the formula for it. How many sides does an n-sided polygon have? We don't know. It doesn't give us the number. But it told us that number's name is n. How many triangles can you make once you know how many sides you have? It was always 2 less, 2 less. This should also be 2 less. Whatever you started at, take away 2. 20 take away 2, 18. 6 take away 2, 4. Whatever you have, take away 2 tells you the number of sides. Tells you the number of triangles. Each triangle is worth 180 degrees. And so, to find the angles in any shape, you take the number of sides, subtract 2 to find the number of triangles, and each triangle is worth 180 degrees. That is the formula for any shape you want. Melanie, or Mulaney, says that since a decagon would mean 10 sides, comes from the word decade, 10 years. Since a decagon has twice as many angles as a pentagon, I'm cool with that. A pentagon has 5 sides. The angles in a regular decagon will be half the size of those in the regular pentagon. Is she right or wrong? Calculate the size of the angles in the regular decagon to verify your conclusion. Okay. Decagon, 10 sides. Let's practice our formula. The formula says n minus 2 times 180, where n stands for the number of sides. In a decagon, what's the number of sides? I believe there's 10 sides. Ten minus 2 is 8 times 180 degrees. Whoa, almost dropped it. Yeah, I did drop it. 8 times 180 degrees is 1440. So in a regular decagon, the total of all the degrees is 1,440 degrees. And since it is regular, we can split those angles in 10 exact pieces to get this size and this size and this and this and divide them all out. That's 144 degrees each. This one's 144, this one's 144, this one's 144, and so on. And that way when we have 10 of them all together, we'll make the 1,440 degrees in total. It's a lot of words. How does that compare to our pentagon? Well, let's go find pentagon. I don't want to do the calculation again. I'd be happy to just sort of, ooh, that's supposed to be an N. And pentagon. Why don't we just go up here and say, inside of a pentagon, each angle should be, oh, we don't know that. Why don't we go here? Inside of a pentagon, the total is 540 degrees. That means each angle should be 108. So in the decagon, it's 144 degrees. In the pentagon, each angle is 108 degrees. Is Melanie right or wrong? It's hard to imagine her being wronger, actually. She said the ones in the decagon should be half the size of the pentagon. That would be 54 degrees? They didn't get smaller, they got bigger. She's so wrong. So wrong. And I'll be honest, when I did this example the first time, I couldn't explain why this example even existed. She was so wrong. I didn't get it. I get it now. It actually changes on one word. That's the word. If she's doing the angles not in a decagon, but the angles on the outside of the decagon, she's bang on. What's the exterior angle here? Well, 180 minus 144 is 180 minus 144 is 36 degrees. And if we go to the pentagon exterior angle, I don't want to figure it out again. I'm just going to cheat for the answer. What was the exterior angle of the pentagon? Do you see that the exterior of the pentagon is 72? The exterior of the decagon is 36. It is exactly half the size. She's bang on. She just got one word wrong. She said the angles in. She should have said the angles on the outside. Good luck with your assignment. Ask lots of questions. See you soon.